talk about stationary process, stationary stochastic process. And that is very strict, right? Because it talks about the same distribution, the same joy distribution, emphasize on the same joy distribution across time, which is very strict because according to the definition, we can pick any time index and distribution have to remain the same. However, usually when we use in econometrics, we're using some a weaker form of stationarity. That is what we call covariance stationary process. Okay, so let me talk to you about a little bit about what is covariant stationary processes means. So this is a type of stochastic process. Xt. So this is, we talk about just one series, right? Just one variable with a finite second moment. By second moment, I mean the variance, right? So the second moments mean the expectation of xt square is less than infinity. So it's not that the square of this sequence are not like go to infinity. So is this stochastic process with a finite second moment is covariance stationary if one, the expectation or the first moment is constant, so the mean or the expectation is constant. Second, is the variance of xt is also constant. And lastly, third is that for any t and n h, I think h is more than one, right? The covariance between xt and xt plus h depends only on h and not t, and not on t. So it called covariant stationary because it's focused on up to variance and covariance of the relationship among variable in the sequence, in the process. When we talk about stationary stochastic process, we talk about the same joy distribution. And when we talk about joy distribution, it's more than covariance, right? It's too restrictive. So now we just like let go of the joy distribution, which is say that as long as the expectation is constant, the variance is constant, and then the covariance of any sequence of any member in the process is only depends on the h but not on t. So for example, if we talk about, right, if we pick a covariate of x in 2000 and x in 2002, and then we pick the covariance between, again, x in 2020 and 2022, that should be the same. Okay, why? Because the gap between these two, h equal to 2, right? Same with that h equal to 2. So the the covariance stationary focus on the fact that the covariance between any two member in the process, even though they are far apart in terms of time, right? So that 2021, sorry, I had too many zeros. Okay, correct. That 2020, right? So this is quite far apart, but if we pick the two member that is 2 years apart, and this is also 2 years apart as well, so the covariance should be the same. Because if the covariance depends on the h, so it depends on how far apart the two members, but not on t. So even though we talk about two member and two member far apart, but as long as that member of the process is 2 years apart, the covariance between them should remain the same. So again, we want something that remains the same so that we can use the data to estimate the same thing, right? But we are not assuming that it have the same joint distribution. We just assume that it have the same covariance. Yeah. And weakly dependent process, just like on the top of that, it talk about, okay, so this is like the covariance depend on h, but not on t, but how far. We assume that for the weakly dependent, we assume that if is the time, right? If the sequence is quite far apart from one another, the dependence between them have to reduce to 0, so that they become unrelated. So let me add a little bit more about what is weakly dependence. Okay, so when we talk about weakly dependence, right, we talk about stationary. It has to be stationary time series first. A stationary time series process is said to be weakly dependent if xt and xt plus h are almost independent as h increases without bound. So that means that if h increases to infinity, so if we talk like if it's stationary, right, covariant stationary, So it means that the covariance depends on H but not T. But if H is big enough, for example, if instead of 2, we're talking about 100. So if the two members of the process is like 100 times away from one another, if we can assume that they are almost independent, then this stationary process is also weakly dependent. Right? In cross-section, each observation is independent because when you sample from the population, you use random sampling, so each observation is independent. But in time series, I told you that one of the characteristics of time series is that it's dependent, not independent, because it's the same variable, but it's just like observing over time, so it should be correlated with one another. However, if it's quite far apart in time, it should be roughly independent. And if that is true, then we say that the process is weakly independent. Weakly dependent. Yeah. Anyway, that is just notation, but remember that when we assume TS, okay? So again, when we talk about TS1 dash, right? We have to combine TS1 dash with TS3 dash and TS2 in order to assume that the beta hat is consistent, not unbiased, but consistent in time series. So that TS1 dash assume that the time series have to be covariant stationary and weakly dependent, right? So that's why I have to explain what it means to be covariant stationary and weakly dependent, so that we can use TS1 dash instead of TS1. Okay, I think that's it. Yeah, about time. There are many things that both cross-section and time series that I haven't teach you, but I teach you, remember that what we learn is the most basic model. Very extremely basic, right? So many more to learn. And if you would like to learn more, then you have to take more courses in econometrics, which I guess you will. Okay, so I'll see you next time in the final exam.